Hello and welcome, and in this very first lecture you will learn all about current and voltage. So before we go any further, take a look at this circuit. I will be explaining how this works, and all this circuit does is light a lamp. Okay, let's continue. So what is current? Current is the flow of electrons. It is not voltage and it flows best through a conductor. So you can think of current as water flowing through a pipe, right? That is essentially what current is in a circuit. When we pass current through a circuit, it can generate heat. And if this is done unsafely, it can cause components to melt, or in some cases, explode. Too much current flowing through a circuit can actually damage components. You always need to be careful how much current is going through your circuits. Let me now explain this video on current that I showed you at the start of this video. Here you have the battery. This symbol represents our battery. All of these lines represent wires. And this in the right hand corner is a lamp. Think of your lamp at home that lights up when you plug it in the wall. This is our lamp. Let me show you the video. I'm now going to change the voltage of our battery from 0 to 120 volts. And we can see the lamp turns on. See these yellow squares going through the wires? This is a simulation, okay? These yellow squares represent the current going through the circuit. You can see it flows like the water in a pipe. Let's now change the voltage to 0. We can see the lamp turns off. So what is a conductor? Conductors are materials that let current pass through them easily. So examples of conductors is copper. And we use conductors in electronic circuits so that they are most efficient. So what is an insulator? Well, insulators are the opposite to conductors. They don't allow currents to flow through them very well. So around a wire is usually rubber or plastic, and these are insulators. And the whole point of this is so if you put the wire down on a piece of metal, for example, it doesn't disrupt the circuit because metal is a conductor, right? So by putting an insulator around the wire, it means you can safely pick up the wire without hurting yourself or disrupting the circuit. And you can place the wire anywhere you like without also disrupting the circuit. Insulators are great for this. Do remember that insulators are not a silver bullet. If the push of electrons through a wire is too great, the rubber on the wire can actually melt, which has happened to me before. Let me now explain what voltage is. Voltage can be thought of as the pressure in a pipe. It's the push that causes electrons to move through the wire, causing the current. Voltage can also result in dangerous circuits. Let me now show you our video example again, but this time I'm going to show you an example on voltage. So we can see the voltage is changed to 5 volts. Notice how the current moves through the circuit but the lamp doesn't turn on. The lamp doesn't turn on because there isn't enough push. The electrons aren't being pushed fast enough, so the lamp does not light. If we now up the voltage to 50 volts, we can see that the current is much stronger and the lamp is starting to light up. If we change it to 120 volts, we can see that the current appears not to be moving. It is moving, it's just moving so quick that it looks like it isn't moving at all in our simulation. And you can also see that the lamp is now at its brightest. If we change the voltage back to 30, we can see that the lamp has now gone back off, but we can still see the current moving. The reason it isn't lighting with 30 volts is again because there's not enough push through the circuit. So the more voltage there is, the more push. Thank you for watching this part of the course. You can find the next part in the video description.